All right, so let's proceed with the discussion. We started with the concepts on the data types. That's something that we need to look at. So I'll be writing it again and again, as I said. So let's try this. No keyboard, yeah. So data types: integer, float, character types, complex numbers, Boolean type. We also have date type, right? And I'm slowly introducing new things to you. This is binary data. We call it as byte type. And we also have special date type in Python. Okay, but yeah, these are the important things that we will be dealing with on a daily basis. Then we need to look at the data structures. So we'll talk about array, and here we have 1D, 2D. Then we talk about list. Of course, matrix is there. I forgot. Then whenever you talk about sequential data, sequence of data, then we'll have lists, tuples, sets, and dictionaries. And we also have strings. So we are going to deal with strings today. And we are going to learn the module called RE, regular expression. So we will slowly try and look into the packages, the modules. RE module is basically used for textual data analysis. That's string data, right? So we will be looking into this, but before that, let me complete my revision. Then we have operators that we need to look at. And in operators, we start with arithmetic. Then we have assignment. Then we have logical, relational. We also have membership. Then we have identity. And we also have bitwise. Those are operators. Then we discussed about if condition or conditional statements, if else. Then we looked at for loop, while loop, combination of these, right? And then we started understanding about functions. Here we have discussed about custom functions, and the syntax is defined, the function name, then the arguments, and then you are going to write your code. And when you are executing this in Spider, we have to select everything and then execute. That is single group. Then we also talked about arguments that we need to pass when we are dealing with functions. There are various arguments: actual arguments, formal arguments, right? Keyword, variable, keyword arguments. All these are different arguments that we need to work with. And when we talk about arguments or variables, we also have to look at local and global arguments. Then yesterday we studied about modules, right? An extension to your functions. Modules could be collection of multiple functions, right? And we need to have initialization library. This library, mandatorily this function should be there to create a folder as a package. Folder is nothing but where you have multiple .py files. They're individually working. But when you define that folder by having these libraries, right, then it becomes a module. And once you say module, there will be hierarchy into the modules also. Then very important, again, we looked at exception case, right? Exception handling, and we also looked at file handling, open function. And for open, we have two arguments that we will pass for open function. One is the file, the other one is the mode. And the mode can be write, or I should say create, write, read, append. Right? These are the different things that we have discussed. Then we have file exception handling, and it is nothing but a conditional statement where you will have try and except. Try and except. Now next we have regular expressions here. Let's try and understand this. RE, this is basically your regular expression. And whenever we are working with any string data, we need to have this regular expression mandatory. That is the library which is used or required for working with string data. Now, that's something which is mandatory. Right? So we import RE and then we give a string. String is nothing but a list. Right? It is nothing but a list. Okay? So let's see this. So we'll go down all the way. Let me close this. Yeah. So I'm going to say regular expression. And we will import RE package. And let's say I'm going to pass a name, basically a string. So I'll say S is equals to, I can put single quotes, right? Let's say S1. If I put double quotes, then I can say Sharad. I can also put triple quotes, right? Like this. This is also valid. You can either do this or you can say this also. So Python can understand single quote, double quote, or triple quotes. Okay. Now, once you define this, then what kind of operations can you do on strings? Right? Basically, you need to understand what kind of operations can you do on strings. So we have various things. Let's say find all is something that you will be using. It's a regular expression function. Let us do that. So you're going to say RE dot find all. Right? So let us do that. I want to capture some content from a string. Let's write some string here. Okay, I'm saying Sharad is, let's say, 40 years old. This is not my right age, okay? And let's say he is having 16 years of experience. Okay? Okay, let's say he is working for, let me say, working for 360DigiTMG and having 16 years of experience. Okay, this is some kind of a statement, simple string I'm writing. Now I will try to capture numbers from this. Right? So let's see that. So you say number is equal to RE dot find all. Look at that. find all is a function. It says pattern and string. What is the pattern that you want to capture? We need to look into that pattern. Now, whenever you talk about these regular expressions, right, there are these fixed patterns that we need to look at. Okay, and yeah, we can try and get that. First, let's say is my mouse cursor? Yeah. Let me click on that. So here you can see we have documentation available. It says RE, this module is regular expressions, right? And we are basically looking at special characters and all that. Let me scroll up this one. Yeah. So we'll basically look outside the ASCII range, and then we have right, different characters, various things. Then we have special characters, and you can also capture the details like this. S basically means matches non-white space characters. D basically means non-digit characters, right? Then we have various other attributes. But yeah, this is smaller documentation. You can go to any of the Python websites, and there you can get all these descriptions, clear descriptions on what all things the regular expression can basically handle. Okay, pattern basically means here you need to define what is that you are trying to find in the strings. Is it characters like this, or is it numbers like this, right? So those things have to be explained. And string is the string that you are passing as an input, right? So that's a simple logic that we need to mention there in the regular expression code. So let us try and pass the content here. We want to see numbers, right? So we will be saying this numbers are, right? I'll explain that. Let me type this. The same R, then quote, you put slash, and then you're going to mark the number. Let me copy paste. I don't remember this. Really tricky. Okay, this is the pattern. Okay. And then we have our string as. So what this basically is doing is, it is capturing your basically whatever the, right, R basically means return the value, carriage return. You have to return some value, right? What is that return that, what is the value that it has to return? You are representing that in that brackets. Okay, you are representing that as a dictionary or a set basically. Okay, 1, comma 3 basically means you are passing numbers. You are looking for numbers. Slash D basically is, I should say, digits. Slash D means you are passing, you are looking for digits. Okay. Backslash notation that you are saying. That would basically, you have new line characters, new tabs, new space characters, right? Like you have slash T, slash N, right? Similarly, you have slash D. Okay. Now let us try and capture numbers from this particular, just execute it. RE is not defined. Let me import this. Then I have not executed this. And then let's try this. So if you see here, it is capturing all the numbers, including 360, right? So it captures that following a pattern, right? So let us try and apply more such commands, interesting commands. We'll do that. This is for capturing numbers. How about capturing names or characters, right? So let us do that. Let's say str is equals to re dot, or let me say this, name is equals to, or characters is equals to. There are a few keywords that we cannot use or we should not be using. Find all, and here we want to capture the names. So pass this, and here you are going to define the characters like this. Okay, we want only characters, so you'll be first mentioning A to Z, then you'll also represent smaller case letters also, and here you are going to pass your string. This basically is going to look for characters. Right? And it's really bad. It does not capture the names properly. Okay. So it is looking at capital letters. Names which are starting with uppercase letters. So if I say this, now you see it is going to capture my name as well. Okay, but because I'm passing only 2 letters, it is capturing only 2 letters. If you say star, it is going to capture all the letters. Wherever you have uppercase letter coming into picture, it is trying to capture that. So if you say CH, it is trying to capture the pattern like this. So you're saying, look at the pattern where you have uppercase letters followed by smaller case letters. If you see anything, capture that. Right? So that is finding all the values which follow that pattern. Okay? Yeah. 1, 3 is basically the units. You are basically capturing the digits from 0 to 3. 0 to 3 means I'm not talking about 1, 2, 3. I'm talking about the index, values, length. It's the length basically I'm talking about. All right. If I change this to only 1, then it is going to capture only first number. That is, why are you capturing all this? Okay, it's capturing 1 number at a time. Let me put 1, 2. My bad. Yeah. Now it will not capture all the values. Okay, it is going to capture only 2 numbers. Now you see, it will capture values in 2 digits. Okay, that 3 does not mean you are capturing 1, 2, 3, 4, 5, 6, 7. That's not the date. That is captured by digits. /t is digits, right? I told you that. /t is the digits. Yes, that's correct. Alan. So how many digits you want to capture at one go? Here you are talking about list of values, names, which have the pattern. It could be anything between uppercase letters of A to Z and lowercase letters of A to Z. Yeah. If you want to capture what all characters are there in the string, you already have that characters, right? You say minus digits, that would anyways give you that. Now we'll deal with that. Anyways, we'll have to do pre-processing also on the text mining. We'll look into that. You'll remove the minus. Minus, when you do minus digits, automatically it's text data. All right, so this is basically find all. The regular expressions is trying to capture the pattern in the data, right? That's what, in fact, the function is also talking about. When you say re.findAll, it is going to take the pattern on the string, right? Next. Okay, so here you are capturing name. So let us see. This is like substring, okay? We are trying to find a substring in the string, in our string. So let us deal with that. So I will say string or string 4 is equals to okay, let me take this same string, or let me take S1 only. When you say S1, it is the string, and in this string you want to find a specific value, keyword, right? You're basically trying to do find command. So I'm going to say, let's say return is equals to re.findAll. What is the value that you want to find? Let's say I want to capture and. How many times and is repeated in this? All the times, wherever it is having and, it is repeating that. How many times it is repeated? Twice. This is once and this is twice. So it is going to print, or it is going to capture both the entries. That is basically to find a specific string, right? Now you'll also be able to identify the location, index. So this is only returning the file, but if you want to understand the location exactly where this file is, then we will be doing this. It's an iteration, right? It is a list. String is a sequential number, sequential values, where in that sequence you have characters. So it can be treated as a list also, sequential values. So I'll say for, let's say for I in, capture all the values. What values you want to capture? Let's say that re.findAll, you want to do the same and, right? In S1 only, you're typing this, but not findAll. FindAll is basically going to repeat it. I will have to do keyword called find iterator, yeah. And then you're going to pass numbers, comma, S1. Right? And this is a for loop I'm writing because I want to look into the complete list. So let me copy and paste it here. This is the problem. Escape character. Yeah. I just escaped it. Easy. Okay. So for loop, I'm writing here using iterator. Yesterday we have learned about iteration, right? So this is iterator that we are writing. And you want to capture the location. And we have a function called span. Yes, span. And we are writing this function to capture all the locations where A and B is having a print. I mean, wherever it is. Let's say print LOC. And if I execute this all together, it is going to print locations. Wherever this and is there, find all basically is repeating that, right? Wherever it is there, it is repeating. How many? Number of times, basically. But what is that location is given by find iterator. Okay? So this find iterator is used for identifying exact location. When you want to basically rename something, you might want to use this. Find and replace if you want to do, you can do this. So finding is done. Let us do replace now. Right? So in my data in S1, let's say I want to replace a specific value. So I will be using a function called compile. Yeah. To replace a string, I need to use compile and then regular expression command. Let's do substitute command. That is RE command. So first is compile, then substitute. So I'll say S1. This is my string. Where is this? It's not printing output. Yeah, this is my output. So I want to rename some value. Okay. I'll just replace this, right? Any one value here to working is there, right? I'll replace it with work. Okay, let me try and identify that. So first, capture this. I have a pattern working, right? Let me think about this. Okay, letter is equals to re dot compile and the pattern. I want to repeat the same pattern. I'm just trying to see if I have any pattern which is repeated so that I can target that and change it. ing is there only one location. No, nothing is there which is repeating itself. So let me create another text here. Let's say S1 is equals to Sharad is, say, data. I'm thinking of some content. Sharad is old. Then we'll say old okay, let's say this. Old and old, okay? Yeah. Just for that. I'm not that costly also. Right, let me do this. I want to identify a pattern from this particular string, right? Okay, let me say some pattern, and then it could be any character. Say O. No, it's not going to work with this. I'm not able to figure out. Old is there, okay, and then we need to have a pattern which is only identifying this particular value. Okay, G O L D. Right, let me write this one, okay? Yeah. This is a function. Compile basically is going to identify this particular pattern in the string. Okay. Now, we are going to change this by substituting the value, okay? So I will say S2 is equal, so or S4 is equal to, let me say L dot substitute. L is your recompile function, right? L dot substitute. Here you want to rename the value. Let's say I want to say gold. And then I'm passing my S1. So this is a string. Let me see if I can get this. And if I say S4, yes, look at that. Got it. So it's not touching OLD because you are saying there is a character in front of it. That could be anything. You're just saying GOLD. Right? And you want to replace all the values which have the same string. First identify this, then you are saying substitute that pattern using DN. You're just extending it. You can rename it to anything. Okay? This is basically for renaming the content. Right. This is about right, renaming. Then we also have very important right function which is to clean the data. We basically want to clean the values. Okay. Now, in order to clean this, we use the substitute function only. This sub function, right, is very, 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 very handy. And we will be using this very heavily when you are working with textual analytics, text data analytics. Right? Now, we will try and identify the values on which you want to do some kind of cleansing. Let me see what is next. I will be wanting to do the cleansing task. Find iteration, find match. Oh, okay, we should have taken this. We wasted. So there's a lot of code is there. This is if identify pattern, and then substitute is used to substitute the value. All right, look at this. This is for cleaning. When I'm passing my alphanumeric values here. Let's try this, and you will see what this code is going to do when you pass this. So what is this code doing? Anyone? I'm substituting, right, something. We just tried this. Here you see the pattern or syntax. So what is it doing? Not really. Capital first letter for all. No, no, no. Wherever you have characters, this is the big list that you're seeing, right? Wherever you have letters, you are replacing them with what? Comma. You're replacing with comma. That's the string with which you are replacing. That's what we have done here, if you observe. Substituting this to this. L1.sub, that is one syntax. Here we are passing the characters directly inside the function. On what function or what string you want to do, that is mentioned here. So this is your string on which you want to do replace the letters with comma. So wherever there is a letter, that is changed to comma. You can put star symbol. That would change everything to star. Generally, these kind of applications are done, or these kind of manipulations are done when you are working with, let's say, password masking, for example. I don't want to show the password to the user, then you put these kind of masking messages. Right? You might also want to do reverse. If you want to do reverse, let me take everything here and I'll just put cap here. This cap symbol basically means you keep them, right? Except for the letters, everything else will be changed. Wherever you have letters, it is printed as is. When you put cap, it basically means consider. Right? You retain them and rest of the things will be altered with stars. So this is how you play around with your strings. Regular expression is the package. Okay. Remove white space. You can remove white space. Okay, removing the numbers. We'll try these things. These are also very much required for manipulating the text data. Let's do this. Okay. Every camera change to comma. Can't we substitute golden directly in S1 instead of storing in L? You can do that, Sundar. Try out. That is one way. Compile is a function that we do. Compile and sub. That's one of the ways. Yes. Inbuilt functions. Cannot understand. What is that not that you did not understand, Pradeep? I am defining that I want to substitute these values using comma. So these codes are saying this is my key values that I want to edit on. How do you want to change this substitute? With comma. On what? You're going to mention that here. This is your string. Making sense now? Now, if you put cap symbol, it is saying except for this, everything else in the string should be replaced with spaces here. Here you are marking space in this code. Compile is yes, like find. Yes, you are trying to find the pattern. Sub is to replace. Okay, Ripple, in line number 601, S1 is not written. Let me see, what did I type there? This is a pattern, right? keyword. This is why you want to look at string there. Just to entering some character here, you're saying, hey, make sure you're compiling this. When you look into this string for substitution, you're defining this pattern here using compile. You don't need S there. That is done using substitute function. So if you want to run this same thing, you are extending it, right? You are going to define that entire string as S1 and mark S1 here. It's just identifying the pattern in the string that you're passing and replacing it, substituting it. That's it. Irrespective of the size. Okay, let us try and deal with these things now. We want to remove extra white space, right? And we will also look at identifying the pattern here, right? You'll also see whether your values that you're passing are authentic or not. So let us try this. So let me first take a string. And I'm passing the string as my, okay, I am, let's do this. I am Sharad. Let's check. So I'm passing a string like this, okay? You need to put triple quotes in order to get this content set. So you are going to execute everything together to create that string. So if you say S, you can see these new line characters are appended between the data. Okay, because you are adding that into new line. Now you are going to identify new line as a pattern here. So what you use the compile function here. So I'll be using the same code. I'll just copy everything here. Everything same. I'll just use this. Put here. But in place of this, I will put what? /n. So my L is going to be identifying /n. I'm compiling /n when I'm passing this particular command to be substituted from my string. So what I do, I'll remove that. I have to basically identify that, right? So let me identify this string first into that character into my string first. So I'll say new S is equals to N is equals to L dot sub, just like that. The previously we have executed, remember? What is that you want to replace? I want to remove that extra white space. So I'll say, without any space, I'm putting quotes, right? And I'll say S. This is my string. Let me execute this. And now if you see N, that new line characters are removed. If you put space here, right? If you're putting space there, then you are going to get, okay, let me re-execute this. This is your string. Now when I remove this, this is what you're getting. right? Because I'm putting space here now. So in place of new line character, I'm removing that and putting space. Right? So this is how you identify a pattern, find key, it's like find, and then replace it, find all and replace it. That's your compile and sub functions that we have tried in the previous case also. This is another example you can think of. Now let us try and identify the numbers that we were looking at. So in the first example only we see /d. /d basically is the digit, right? So let's say n is equals to numbers 1, 2, 3, 4, 5, 6, 7, 8, 9. This is my string. If you want to see the length of the string, you can check. Length of n. 9 digits. Right? It is basically having 9 digits. Now, in this 9 digits, you want to basically try and capture, let's say, few digits only. Okay, you want to capture few digits from that particular number. So let us try and do it. So you're going to say search command here. And re dot, there is a function called search. So in the digits, in the string, you are trying to find a specific, let's say, structure. So I will say R, and then I will put this tag, and then say /d. This is to identify the pattern. And then I'm trying to capture D. D is digits. And then remember I put flower brackets here. This is to define the length of your string. So let's say I will put 5 here. And then my string is n here. So it is going to search and print first 5 numbers. The span, the values are going to start from 0. Know that, right? 0, 1, 2, 3, 4, 5, 6, 7, 8. This is index. Index starts from 0. And we have 0 to 5 numbers to be captured. I'm saying 5, right? Span is 0 to 5. That means 0, 1, 2, 3, 4. That's what we are capturing here. Search is the keyword which is being used there. Again, if you want a documentation, highlight your mouse cursor and put that. Scan through string looking for a match to the pattern, returning a match object. Now, let us again do this. How many times I have, let's say, 4 numbers, right? I want to check whether the number of values are 4 numbers or not. Okay, let me take this. Okay, I'm defining this as a number. This is my string. And on this numbers, you are basically playing around with changing the pattern. How many times you, let's say, have 3 to 7 values. Right? Let me say the same thing here. But yeah, now let's not look into search function. We will have something called as identifying, right? Find all. So let's do find all. So I'll say re dot find, let's say all, and then we will search for the digits here, /d, and Let's search for values from, let's say, 4 till 6. And this string is number. So if I do this, these are the values which have that pattern. So the last one is not printed because 7 is not there here. And it is printing all those values which has 4 or 6, 4 to 6. Length basically. 4 values till and 6 values. The number of digits should be 4 to 6. That's basically your number. This is to find the size specifically. For example, you are developing an application form where user needs to give phone number, for example. Now you are going to specifically check whether that length is equal to 10 digits or not. If it is not 10 digits, then you are going to throw an exception. Right? You can do that. Or we can also try and do the verification like this. Let's say not phone number, but we will try to do something else. Okay, it says PAN number. Let me show this and explain. It's basically saying PAN number. Okay, let's try this. There's some random numbers I'm passing. Alphanumeric values are there. It's basically passed as a string. And we are trying to find this pattern. Right? We are saying we need to have digits slash D, that's basically digits, right? Then we are looking at the digit sizes, basically 3, and then W. W is basically for checking the characters. So we can do search question mark again. So it's going to search for this pattern. Right? Let us do it with this. Now, if this pattern is matched, then it will print this. Right? If condition, simple if condition I'm doing. So is it 3 digits? No, right? Is it 3 digits? No. So obviously it is going to throw an exception saying it is not a PAN number. Not a PAN number. If I try to change this, it's 3 numbers. I'll still get not a PAN number. Let me change this to 3 numbers. And here, let's say I have 6 values. Then you pass this. It is a PAN number because it is matching that particular pattern. Right? So this is the string manipulations. Similarly, you can also verify email IDs. Let me see your questions. Line 6, not 6. Oh, you're stuck there, people. Why are you stuck there? Line 6, not 6. Replacing space with star. Not replace space. It's not space, it's characters. Characters are getting replaced with stars. Not space. Space will remain space only. You're not touching the space. This is the string in which the replacement is happening. I taking 0 to n minus 1 here. Where I? Which number you're talking about? Wherever you're talking about index, that is going to be alphanumeric Pradeep. It's basically, we say W, word. All right. So we will take a break now. And then we will talk about OOPS concepts. Right? Now, let me take the pen. 9:08. We will connect at 9:50. Yeah, let's connect at 9:50. Yeah, guys. Yeah. Okay. For your question, Alvenu, you should be looking at the scenario as this is a string. It really does not matter whether it is upper character or lower character that you're passing inside the quotes. The pattern should be there. Right? If you are writing an uppercase letter, you have to search for uppercase letter. But inside the quotes, string is a string. Okay? There's no restriction, in short. Right. Okay. At the end, Kumar, we'll discuss that one. Okay. Yeah. All right. So now let us quickly get on with classes and objects. We are not going to spend much time because we have to move on to the data pre-processing from tomorrow. So I will be quickly rushing through a few things here. We will be predominantly doing only theory. I will be running the code. You might want to run this code at a later point of time to understand. So when we talk about Python, remember it also has object-oriented capabilities, OOPS concepts. And whenever you talk about object-oriented capabilities, it is basically having this, what do you call, the objects and classes, right? It basically has objects and classes. Now, object basically is nothing but data. You can look at an object as data. And you're saying object-oriented. So whatever the class that you are defining, the function, the characteristics that this particular data has, right? Based on that, you are defining your classes, right? This is basically what your objects and classes means. So we are, right? If you see this x is equals to 10, x is an object, right? And it's basically having a value called 10. Right? So simple, very simple. Data is your object. And on the data, you are defining some characteristics like this. We have discussed about functions, remember? Functional oriented. Now, this is also a function. You can imagine this class that you are writing as a function. In fact, you are doing a function if you see here. This is a custom function that you are writing. This is a custom function that you are writing, right? So we are writing a custom function, but we are defining the class name. Okay, this is more like a, I should say, module, submodules concept. And it has multiple objects in this class. We have multiple objects. So define class as bike, and it gives this name. And then you're defining these characteristics. Init basically is, remember, a class or is a module which is going to define that as the main function or a package. Now it creates a hierarchy. So you're defining the initialization, library or module. And this is initializing multiple classes here, right, to be linked to this particular global parameters that you are passing. So you're defining self. Self is a global parameter. It is used for mapping the data that you are going to pass to your custom functions to this particular master data. I mean, this is how you can imagine. Okay. Then I'm defining mileage. I'm just putting self here. I'm not defining various things. Once you do self, it is remapping to this mileage parameter. Okay, you say self mileage, that is nothing but your mileage here. Then self.speed, that is going to be your speed. Self.length is length. Self.b is speed. So self is used for mapping. And this is one custom function that I'm writing. Yeah. So I'm just creating some spacing so that it's clear. And because the indentation problem is there, you need to make sure that the spacing right in the page is properly written. So this is your main class. Then you have mileage class, area class, configuration class, and speed class. So you're defining this. Now, when you define or when you call this, this is going to create an instance for your bike class. And you're calling that as comp1, the computation one. You're initializing or instantiating your class. Right? We call it as constructor. It's nothing but your instance is begin. And you're passing your parameters when you're initializing your function. And then if you say comp1.config, it is redirecting this computation one that you have passed here to configure file, the config function. Right? So it's basically going back and executing that to bring in that particular custom function that you have written inside your class. It's basically mapping. So this constructor is important. This is going to basically kickstart this instance. Right? And you can also say comp1.getMileage. It's going to capture this part and it is going to read this 55 as an output. You're just printing that value, right? So it's simple class that I have created using object. Now, if you're a programmer, you might feel it is nothing, but if you're not a programmer, then it might feel a little complex. Classes and objects and all that. Don't worry, you don't have to learn this. You don't have to, right? Because as a data scientist, this is not your job. But understanding the basic minimum terminologies, it's good. Then we have inheritance properties. Whenever we talk about object-oriented programming, we have something called as inheritance. Inheritance basically means you are getting the capability from upper level classes. So if I have to explain this in a very simple terms, right? I always say you inherit property from your parents. Your parents have inherited property from their parents. So on and so forth, right? It's not about property, it's about various things. Like, for example, few people have hereditary problems. That is also inheritance. So it is basically being passed on, right? It's basically being passed on. So let's do that. So here I'm defining class A, simple class, and I have two functions in it. Okay, product 1, product 2. And I'm creating a constructor here, and I'm printing this. So it's basically giving product name. It's just printing this. dummy function, you're just putting a print function there and it is printing name1. Now we are talking about inheritance. Here I am writing class B, product 3 and product 4, and I'm defining a constructor here. This is your constructor for B, and you're printing B, name B. Okay, if you print this, it is going to give some value. Okay, it's basically your constructor ID. Okay, now here you are also printing product 3. Product 3 means it's going to print name 3. So let us print this. It's taking a unique ID and it is printing this command, right, in your function. But I also want to call product 1. From this constructor name B, I'm calling product 1. Now when I execute this, do I have product 1 here? I don't have. But it will execute fine and gives you the output, because when you're defining your class, you pass this value, this particular class, as input here. You're passing that as an argument for this class. Class A arguments are there for class B. So automatically, all the properties or all the features of class A are going to be working with class B also. Similarly, you have class C. I'm not passing any argument here. Okay? And if you see, for class D, I'm passing A and C, both the objects. So it's like you're getting property from your father. Here you're getting your properties from your father's side and your mother's side, right? Multiple inheritance. So you get product 1 for D also, class D also. So very simple. Inheritance is basically going to get the values from your inherited, the primary class. Okay? Master class and subclass, you can call that. Right. Then we also have another feature called polymorphism. Okay. Now, polymorphism basically means polymers, right? What does polymorphism means? Anyone? Polymers? Can anyone give any synonym here? Random number? No. Many names, giving names, okay. Replication, very good. Single interface, multiple behavior, you can say that. Okay, we can take in that way also. Okay, let me show you polymorphism. So it's basically this. Okay, I have a bird class. I'm defining this bird class. Okay, and I'm calling intro. And I'm calling flight. So these are two different functions that I have defined for class bird. Okay. Now I also have two other classes. I'm calling sparrow and ostrich, two different birds. But I'm passing this master class here, so that sparrow class will inherit the properties of bird class. But if you observe here, you see flight is defined there, flight is defined here also, in sparrow also. So you have same name, same function is there, right? Flight. But within that flight, if you see, here it says most of the birds can fly, but some cannot. Sparrows can fly, ostriches cannot fly. So if you see, for the same flight, there are three different outputs, right? Now I'm defining this, three functions, bird class, sparrow class, and ostrich class. And I'm defining the classes here, or instantiating the constructors. Now, when I say flight, but with respect to bird, it is going to refer to this. Right? It's calling most of the birds can fly, but some cannot. But if I say flight, same flight function, but with sparrow, it gives this particular result. And similarly, when you do it for ostrich, it is taking that respective ostrich. So polymorphism, right? Same name, but different output. Right? So that is your polymorphism capability. So these are OOPS concepts, basically, high level. Then we also have a threading, multi-threading. Again, this is also something that I will not deep dive. I'll just quickly walk through this. Multi-threading basically means, see, whenever you talk about multi-threading or threading, right? We are talking about parallel processing, multitasking. Each thread basically handle one particular task. Thread is nothing but a process or a task, right? Which your processor has to execute. Now, when you have multiple threads, right? And if you have multiple cores, then Python will basically define the process in such a way that these processes can be executed parallelly. Okay? So thread is nothing but a sequence of instructions which needs to be getting executed within a program, right? Irrespective of other codes. One code, one task, it gets executed as one thread. Okay? Now, we are looking at multi-threading capability. Multi-threading means what? You are basically executing parallelly multiple threads or multiple tasks by one process. Within one process, you can have multiple threads. Okay? Now, our programming is a single-threaded software, whereas this is multi-threaded software. Right? Multiple threads will be there. And each thread has its own code to get executed, okay? And Python basically enables you to do that. Of course, there's something called as, right? A problem in Python, especially when you're talking about multiple processing, right? Then it has an issue with respect to parallel processing, right? And it's called as global lock, GIL. L means lock. I means interpreter. Yeah, it's global. Yeah, it's global interpreter lock. It's a very famous problem for Python. Though we say that, right, Python has multi-threading and all that, eventually in the end, each thread is getting executed sequentially only. You cannot have parallel processing. And unless until one thread is completing, you will not get other thread to be processed. So yeah, GIL is a very popular issue that we have in Python. It's not a deadlock, I would not say. Yeah, it's kind of a deadlock. It's just waiting. It's not a deadlock where it is waiting for this and this is waiting for that, but it's a lock. That's one of the problems in Python, GIL. These are all advanced concepts, folks. It's not required at this point of time, but yeah, just to give you the feel of it. So if you see, I'm executing this code where I'm importing time. Time is a function. which basically records the time. We'll be able to capture the time here. You're calculating squares of numbers, okay? You're passing numbers and then calculate square numbers. For each value, you're basically calculating squares. You're also writing another function with cube. And when you're executing, right, for each calculation, each number that you're going to calculate, you're also asking the code to wait for 0.2 seconds. Okay? So let us execute this. Two different functions I have executed, define, and I'm defining a list here. So when I execute this, look at this. 0.2 seconds it is waiting. Similarly here, right? 0.2 seconds it's waiting. Let me change this squares function to 0.4 seconds. Let's try this. So the execution is a little delayed, right? Because you're asking the code to wait for 0.2 seconds. So let us now look at the time. This is the time, okay? We are recording the time here and initializing two different threads for these two functions. Parallel threads I'm passing. This is to initialize the threads. Threading.thread. And then you're executing t1.start, initialize the thread, t2.start, second thread also you're initializing, and you're putting join. t1.join, t2.join is basically to make sure that it's waiting for t1 to give access to t2, and t2 is waiting basically for t1. And you can see cube, square, cube, square, cube, cube, square, square. Right? So it is basically, okay, I have to reinitialize this. My bad. And look at that. Right? So it is first picking up cube, then it is doing squares, then cube, because we have defined that squares have to wait for 0.4 seconds here, right? So let me say 0.2 again here. Let me redefine that. And let me reinitialize the threads and execute it. Now squares are started. Squares are quicker. You can see one square, one cube, one square, one cube. Because both of them are waiting for equal amount of time, 0.2 seconds. Right? So this is how you can start parallel threads and then get these things executed. Okay, so this is about your parallel threads. Okay, next. This is kind of important. Comprehensions. Comprehensions basically says how well or how quickly you can get things executed. Can I find an easy way to write iterative, these kind of iterative functions? Okay, so let us look into this. So I have the special characters and you're reading those. And you have order, and this order basically is to identify the values of those special characters. You can basically give any special empty list also here and execute this. So what I'm doing here, I'm trying to identify each value for this symbol. Okay, Lakshmi Prasanna raised her hand. Okay. I think they're OS control. That's Upendra. Yeah, there is a lot of big story behind that GIL and all that. It's a known issue, and there are solutions for that also. All right, let's look into the list comprehensions here. So list comprehensions basically are, as I mentioned, a way to handle code in much more easier and elegant way. So if you see, I have these 6 different symbols and I'm reading the value of each of the symbol using a for loop. right? I have 2 lines there. I'm defining 2 lines. I'm defining codes as a list, empty list, and then writing a for loop, capturing each value or each symbol there, and then appending a value to it, right? And when you type codes, you will get this values filter. This is one way to do this. The alternative way, if you see, I'm writing the for loop inside the list itself. I'm creating this as a list, right? And then say ordered symbol for symbol in symbols. So same for loop, but the way you've written the code is reduced. Okay? Look at that. 36, 162, 163, 165, 8364. Okay, focus on what we are learning, guys, not the symbol details and all that. It's not required. It is ASCII characters. Every program has that. These are byte values. That's not important. If I pass a list, how do you do that? Focus on that. I'm saying this is a repetitive task. If you are doing a repetitive task, then there are 2 ways to do it. One is to write a for loop. The other way is to do this comprehension. List comprehension. We call this as list comprehensions. You're condensing the way you are executing your code. This way, your code becomes more optimized, right? This is list comprehensions. We also have dictionary comprehensions. You can do set comprehensions. Any object, any data object which has sequence, iteration to it, any iteratable object, in short, we can do comprehensions. So if I do dictionary here, dictionary, you remember, it is always kept in flower brackets, and it has key and value pair mapping, key value pair mapping. So I'm calling numbers. Range 10 means from 0 to 9. That will be my numbers. And then I'm defining an empty dictionary. Into that empty dictionary, I want to add the values which are even numbers. I want to capture only even numbers from that range value, 0 to 9. So I'm writing this for loop, then I'm dividing the numbers, then identifying the index, then I'm passing the squared of those values. Right? You identify even numbers and then square it. That's the logic that I'm doing here. If I execute it, you can see from 0 to 9, it is capturing the even numbers and squaring it. Key and value pair mapping is basically being done here. Right? Now the same thing is done in this form. So you're saying n colon n square, this is your key value pair mapping. That would be the result. For what values? For each and every value which satisfies this condition from this n. Numbers. And in numbers, if it satisfies that condition, put that in this format. Execute this. Get the same result. Right? You can also do this. There's another number, another example here. A colon 1, B colon 2, C colon 3, D colon 4, right? Now you might also want to try implement the same logic on lists. Create a range of values from, let's say, 1 to 9 or 1 to 10 or whatever the number is. And probably you want to identify odd numbers now. Right? Print odd numbers. So you are going to put a condition which is not equal to 0. Right? Rather than writing a for loop, do comprehensions. Put it in a single line format. Becomes very easy. So here also I'm putting this dictionary. I've defined that I have 5 values. This is my dictionary. Then I'm identifying the keys, right? Key value pair. You're saying keys star 2, multiply it with 2. Value also multiply with 2 for each and every key and value pair in this particular dictionary. When you do this, for key values, it is a string, right? So it's just A and A. And for numbers or values, it is multiplying with 2. It's an integer, so normal multiplication happens. Then we have enumerator. Enumerator basically is the index. Simply, it is identifying the index, defines the index. So if you say grocery, bread, milk, butter, this is my list with 3 strings. If you say enumerate, it is going to give you the numbering. It is identifying the value or object, indexing it. So you just have to use enumerate. That's the key function that you are going to do. And if you say enumerate grocery 10, that means you are trying to give the index to be started from 10. If you don't pass anything, then it is going to read or start the indexing from 0 itself. So that's basically an enumerator. Then we also have zip values, zip and unzip functions. You are basically defining name, roll number, marks, and you are saying zip this value. Right? When you say zip, it is basically condensing everything into a key value pair mapping. Right? So let's deal with this. Yeah. So when I execute it, you can see it's basically name, roll number, marks. You are putting it as a set, so it becomes unordered. There's no order. It's basically unordered. Okay. You can also convert it into a list or something like that. Then you might also give index to those values. But yeah, see, Astha is getting mapped with 2 and 70. Manjeet is getting mapped with 4 and 40. But because there is no order, you can see this. There's no order basically. It's just condensing the data into the 3 different values, 3 different sets you might think of. Then we have unzipping. You just say this function zip star map, then it is going to unzip the values. It's separating each character or each value from the zipped sentences. It's not it's not a dictionary, Pradeep. Dictionary will have key value pair mapping. It's not a dictionary that you get. It's just condensing the values, that's it. Okay, then we also see this already. This is basically nothing but it's generating those values. For special characters, you are trying to get values, and that can be done using order, O-R-D. Then we have something called as ellipses. Let's not discuss about that. Augmented assignments with sequences. This is also not required. Yeah, built-in sort functions we'll talk. Built-in sort function. If you remember, we did sort function previously also when we were working with lists. tuples, right? Strings. At that time, we did work with sort function. But here I'm using sorted function. These are two different things. You can see this is sort function, but I'm doing sorted function. Okay? So I'm defining animals. Okay, let me show you here. In Spider, I would like to show this. So animals, you're defining animals, dog, cat, sheep, goat. Then you're saying sorted. When you do sort, you get the values sorted based on their alphabetical order, the first character. C comes first, then D, then G, then S. This is a simple sorted function. But there is something to it. We need to understand that. Okay? By default, it is ascending order. You have to say reverse is equals to true to arrange them in decreasing order. Now, by default, the keyword or the value on which it gets ordered would be the character itself here. But you can also pass some additional key parameters to, right, sort it. So key is equals to length. So you're saying length of that each string is going to define the order. For example, here I'm saying length and reverse is equals to true. That means you're doing decreasing order. So sheep comes first because it has 5 characters. Then goat 4, dog 3, cat 3. Right? Now, if you do length is equals to key, if you remove that reverse is equals to true, it is arranging in this reverse order. Dog and cat will not get altered. It will be same as your original data because dog came first, cat came next in this. So that order remains same. Then we have this sort function. Let me also execute this. Right? Animals dot sort. Now what happened? Let me define it again. Animals is equals to dog, cat, sheep, goat. Sorted is equals to animals. But if you see, this remains same. The values in the variable or the object does not get altered. The output is getting altered and printed. Only the output gets printed like this. But when you do this sort function, this is an in-place function. In-place means it is altering the value itself, the object itself. Now you see the object got adjusted here. Cat, dog, goat, sheep. So, and sorted function is not an in-place function by default, whereas sort function is an in-place function by default. So we need to understand in place. Okay? Yeah. Okay, this is arrays, memory views, DQs is not required. It's not required. Missing keys is exceptional key, exceptional handling. We have already done this. Let's not discuss this also. We'll move on. Function annotations is not required. These are all advanced things which probably may not be required for you people at this point of time. Higher order functions are there. Then procedures versus functions, peer functions. Yeah, lambda function is something that we'll discuss. Okay, we'll stop here otherwise today. We'll discuss about lambda tomorrow and then we will talk about data pre-processing from tomorrow. We'll start discussing about your packages, pandas, sci-fi, right? Then we have scikit-learn. So those things will be started tomorrow. All right. Animal dot try out Sai. Okay. Did you try and execute Ripple? Did you execute these two? Execute. First execute. I'll wait. You execute. Done. Oops. No, that's okay. You don't have to open Spider. You can open anything. Jupyter is also fine. Open. Try out. Execute that. Okay, fine. People who are done, who wants to drop out, you may drop out, guys. Thank you. Good night.